Alrighty, last section of this review, number 10, which best explains what happens in the mitochondria. We know that the mitochondria make energy, or ATP, through cellular respiration. So we have to find the answer that has something similar to this process. Energy is needed for carbon dioxide to form sugar. Carbon dioxide is not one of the reactants of cellular respiration. Cellular respiration is actually glucose plus oxygen to make carbon dioxide and water and, of course, energy, ATP. So it's not carbon dioxide that's needed. Water and light are needed. Water is not needed, neither is light. This probably describes photosynthesis. Oxygen releases energy. Oxygen is needed, but it is not the reason that the cellular respiration process produces energy. In fact, energy is actually used from the glucose. And D, glucose molecules are used to make ATP, and this one would be the correct answer. So glucose is used to create that ATP, the energy. So it is D. Number 11, circle the numbers that are incorrect. So this one is comparing mitochondria and chloroplast. So mitochondria are found in both plant and animal cells. This one is absolutely true. Plants use photosynthesis to make food, glucose, and then that glucose is used by the mitochondria to make energy. Mitochondria produces glucose. So the mitochondria, again, makes energy through cellular respiration by using glucose and oxygen, not makes glucose. So this is not correct. The one that produces glucose is actually photosynthesis, which happens in the chloroplast. Produces carbon dioxide. We see here that with cellular respiration in the mitochondria, carbon dioxide is indeed a product. So number 3 is correct. So 2 is the only one wrong in this section. Let's look at the chloroplast. Cellular respiration occurs here. Absolutely not. The chloroplast has photosynthesis happening. So number 4 is incorrect. And number 5, cytophotosynthesis. This one is correct. So numbers 2 and number 4 were incorrect. Number 12. Which two systems can control and balance the carbon dioxide and oxygen exchange in the world? These are the same processes that we are describing in these tables right here. So that is photosynthesis. Photosynthesis produces oxygen through the reactant carbon dioxide, and cellular respiration, which makes carbon dioxide and uses oxygen. So both of these flip the usage of their gases, carbon dioxide and oxygen, therefore regulating it all over the world. All right, now we're moving into things that we didn't get the full chance to go over, so I'm just going to quickly go over this. Number 13, describe each organism in this food chain and what their diet consists of. So the producers are always going to be my plants. They are going to get their food from the sun, so they are photosynthetic. My primary consumer here is a little snail. The snail is going to eat the plant. That means that my primary consumers are usually herbivores. They consume plants. My secondary consumers are going to consume the primary consumers. So your secondary consumers start to be carnivores, but they eat insects. The tertiary consumers are the big, bad, scary ones that eat the secondary consumers. So your tertiary consumers are completely carnivores, and they eat the secondary. So they eat this one. So this is a food chain, and it is a chain because each one eats the one below it. All right, number 14, we have a little bit of math coming up. It's pretty easy math. With every level of this pyramid, only 10% of energy is transferred up. So in this problem, if the producers have a total of 500,000 joules, which is a unit of energy, so we start with 500,000 joules of energy down here, only 10% is transferred up. How much energy do the tertiary consumers have? So if only 10% of the energy is transferred up, we are going to delete a 0 as we move up. So this top one would have, instead of 1, 2, 3, 4, 5 zeros, it's actually going to have 4. And then instead of 4 zeros, we're actually going to have 3 up here. And instead of 3, we'll have 2. So your tertiary consumers are actually going to have 500 joules of energy, because you only transfer 10% up. All right. 15, arrange organism, ecosystem, biosphere, community, and population from biggest to smallest. There's a picture, makes it really easy. Biggest is the biosphere. And the smallest goes this way, so it goes ecosystem.
I'm going to stay muted until class starts, just because Ms. Rutherford
Community.
so I want her to be able to hear.
Population. And organism. All right, last but not least, you need to study this picture. There will be 2 questions on the test that ask you to identify relationships between mutualism, commensalism, and parasitism. This is a really good picture to study what each of these 3 mean.